every day.
Yes.
Wow, that's nice. Okay, look at the question that we have now. So I want us to quickly push this question 7. Uh, First question, it says that determine first principle, the derivative from the first principle if f at x it's equals to x squared plus 4x plus 1. So I'm going to rewrite my equation this side. You can see my screen, right?
Yes, sir.
Okay, so this will be, they want us to find f at x. It's okay, f at x is equals to x squared with minus 4x plus 1. Right. So when they say f prime from the first principle, so I'm not sure, but if you still remember the first principle, it goes like f at prime is equals to the limit as h approaches 0, then
Yes.
we say that we need to find f at x plus h, okay,
Yes,
minus
sir.
f at x. Then we're going to take everything there, divide everything by what? Divide everything by h.
H.
Right. So now you know what I'm going to do when I have this type of question. First thing first, I need to find f at x plus h. So meaning that on the equation where there's x, I'm going to substitute that x plus h and see what I get. Where there's x, I put x plus h plus 1. Right. So if I expanded the bracket here, this is x plus h into x plus h minus 4 into x plus h. Okay, therefore, let's multiply out the bracket. But already, since we work with x plus h squared most of the time, already we know that when we multiply the bracket, this is x squared plus 2xh plus h squared. Then we minus 4x, then minus 4h, then we have plus 1. Are you with me on that?
Yes, sir.
Can I take this and substitute it on that limb?
Yes.
Okay, let's quickly do that. We know that the limit sh approaches 0. My f at x plus h, I'm going to sub in this, which is the x squared plus the 2xh plus h squared. And then I'm going to rewrite that part there. Let's subtract, okay, f at x. So please make sure that when you subtract f at x, you put it inside the bracket. This is one of the things most learners forget to do, so that they can multiply out the bracket with that negative, okay? Then this is
Okay,
over
sir.
h. You still with me?
Yes, sir.
Okay. So now, what do I get when I multiply out the brackets?
Um, Let me just multiply it. The bracket is
Yes,
going to be negative x squared plus 4x minus 1
plus 4x minus
plus 4x. Yes.
1. Then over h. Can you please
Yes.
give me as I continue with this one? So now I'm going to look at the like terms. I'm going to cancel out those like terms. Now, I'm going to look at
Mm-hmm.
the like terms and then we cancel those guys. So the x squared cancels with minus x squared. And then
Yes.
the 4x cancel with minus 4x. And then the
Yes.
minus 1 cancel with the plus 1. So a quick tip is that whatever that you have on f at x, it will be like everything will be cancelled inside that f at x. You understand?
Okay, sir.
Then after cancelling out of the terms, you need to rewrite your equation carefully. Make sure that you don't miss any term there. So this will be 2xh, then we have plus h squared, then we have minus 4h, and everything is divided by h. So when I look at the top part, I can take out h as the common factor, because now we cannot do a direct substitution. If we do a direct substitution, everything will be a mess. We're going to get a 0 at the denominator of 0, which is
Yes,
undefined.
sir.
So from this part, I'm just going to take h out as a common factor. I'm left with 2x plus h minus 4. And when you divide this by h, the h cancels. I'm left with the limit as h approaches 0 of that 2x plus h minus 4.
Minus 4.
Let's do the
Yes.
substitution. Now, when you
Now
substitute, you
make
drop the
H4
limit.
0.
Okay?
Sorry, sir, you can speak.
You say?
No, sir, can speak. Sorry.
Oh, okay. So this is 2x. Where there's h, we substitute 0. Then the final
Yes.
answer is just 2x minus 4. Okay?
Yes, yes, sir.
Right. Look at this. Né? Another exam tip that I can give you is that when you apply the limit, the first thing you can just factorize. I'm sorry. You can differentiate this using the rules. So if you use the rules, this is 2x minus 4. So those tells you that after using the principle, your answer should be 2x minus 4. So if you work out this thing and you find 2x minus 4, then that's when you can start smiling when you are in an exam. Né?
Okay, sir. Thank you.
Okay, let's look at the next question. If f prime, oh, they want us to find f prime. If we have, so this one we have to apply the rules, né? On 7.2, and we need to apply the rules. So we have f at x, which is equals to minus 3x to the power 4 plus 5x squared. Therefore, the f prime at x. So I think it's best if we just rewrite this equation this side, and then we'll work on it. So this is 7. Okay, so this is 7.2.1. Okay, so we are looking for f at x, which is equals to minus 3x to the power 4, then plus
Plus 5x squared.
5x squared. The most important rule of differentiating is that if I have f at x to be x to the n, the derivative of this, the f prime of x, will be the x comes down, no, the n comes down
N comes down.
to multiply the coefficient of that x. So this will be equals to n times x to the power n, then we subtract 1, right? So
Yes.
this will be, we need to find the derivative here. We're going to bring the 4 down, which is minus 3. We multiply that by 4. And then this will be x to the power 4. We subtract 1. Then plus 5, we bring the 2 down, multiply that 2 by 5. X to the power 2, we subtract 1. Therefore, what do we get there? What is your f at x? If I work out this, my f prime will be minus 12 x to the power 3 plus 10x. That's the derivative, right?
Yes, sir.
This was an easy one, but when we look at the next one, this one, we need to first remove the sides. We need to remove that square root. We need to remove the fraction before you do anything. Né? So they say dy over the x, meaning that differentiate y in terms of x. So this will be 2.3. They want us to differentiate y in terms of x. So we are given y to be the root x minus 2 over x. We need to rewrite this equation. I'm not sure if you still remember the laws of exponent. If I have x to the n, the root m. So this can be written as x. The exponent inside the square root comes on top, divide by the one that is outside.
Yes.
So this is to the power
Yes.
1 and this is 2 there. We can write this as x to the power, the 1 comes on top, then the 2 as your denominator. So this is the same as minus 2. Remember, 1 over x is just x to the power minus 1. We can write that as a negative
Yes.
exponent, okay?
Yes.
Now you can differentiate. So we can find the dy over dx. So when we differentiate, the 1 over 2 comes on uh, in front, then x to the power that 1 over 2 is subtract 1, minus 2, which will be multiplied by minus 1, and then we're gonna say x to the power minus 1 minus 1. Therefore, when we work this out, what is dy over dx? This is just 1 over 2. X to the power 1 over 2 minus 1 over 2 is just minus 1 over 2, right?
Yes.
Then we're going to add 2, x to the power negative 2. Okay, so you can leave your answer like this, or you can just put your answer in a positive, or if you want to bring back the fraction, it's up to you. So you can simplify this further and say this is the same as 1 over 2. We know that this is 1 over 2 and is divided by x to the power 1 over 2. And then plus this is 2, which is divided by x squared. You can also put in the fraction and say this is 1 over 2 over the root x, then, yeah, and so on. 2 over x squared. You understand?
Okay, sir.
So it's up to you what you want to do about that. Okay, let's look at what we have on the next question. What are we required to do? They say that determine the equation of the tangent. They want us to find the equation of the tangent to a curve of h at x. Okay, so this is our main graph, and then the tangent should touch that graph at one point at x is equals to minus 2. You understand?
Yes, sir.
So this tells us that if we can find h at minus 2, we can find the corresponding y value. Okay, so when you have the corresponding y value, we're going to know where it touches the graph. You understand? At which point, because
Okay.
already we have the x, and then we can find h at minus 2 to know where does this touch the graph, the point of contact. Then after finding the point of contact, I'll explain why we need the point of contact. Okay, so first thing first, I need you to use a calculator. Punch that on the calculator. Tell me what you get. What is h at minus 2? On the calculator, where there's x, you put minus 2. What do you get? So because this is h at minus 2, it's equals to minus into minus 2 to the power of 3, then plus
Sir,
2. I'm listening.
what is age?
What is h?
Yes, where is it on the calculator? We didn't do it like this.
Please come again. What are you saying?
I don't know where age is on the calculator.
No, why do you want h on the calculator?
Can't it you say put age?
Oh, no, I'm saying on h, where there's x, you put minus 2. I'm very sorry,
Oh,
ne?
I was lost now. Like, where is age?
No, I'm sorry. On the this will be h at minus 2. So meaning that where
Yes.
there's x, we put minus 2. Sorry, ne?
Okay, sir. Thank you.
Therefore, what is the corresponding y value? What do you get?
Um, it is. It's -1.
Okay, so if this is -1, therefore the point of contact, the x is minus 2, the y is minus 1. I'll
Minus
explain
one.
why. Because remember, the standard form of a tangent line, it's a straight line, so it should be in the form of y is equal to mx plus c. We're going to use that point to find c. But now let's first find the gradient. We know that to find the gradient of a tangent at a point, we find the derivative and then we substitute that x value to find the gradient. Do you understand?
Mm-hmm.
So we need to find the derivative of that h. So I'm going to work on the derivative. I'm going to look at the derivative. Then after having my derivative, I'm going to substitute where there's x, I'm going to put minus 2. So the derivative h prime at x, this will be equal to negative 3x squared, then plus
Mm-hmm.
2. So that is the derivative. Né? So
Yes,
now
sir.
on the derivative, to find the gradient where there's x, we need to put in minus 2 plus 2. Therefore, the answer that you get is going to be your gradient. It will be the value of n. What is that? So this
Okay.
is 6 plus 2. Né? Eh? Is it? Oh, this is 2 squared.
Yes, sir.
It's minus 3, which is 4. And then 4 times 3, that's minus 12 plus 2, that's negative 10. That is the gradient, right?
Yes.
So
Okay.
you see from this equation, I'm going to substitute in my gradient, y is equal to minus 10x plus c. Then use this point. So I think you understand why we had to calculate the point of contact. So now we
Oh,
need to use that point of contact to find the corresponding, the value of c. So where there's y, I put minus 1, and this is equal
okay.
to minus 10. Where there's x, I put minus 2 plus c. Then you just have to take it from there and solve this guy. So this will give us minus 20 plus c, and then this is minus 1. Oh, this will be positive since it's a negative and a negative. Therefore, the 20
Negative
will go
21.
to the other side to be negative. So negative 21
Negative 21.
is equal
Yes.
to c. So what is the equation of the tangent at that point? Therefore, the equation is y is equal to minus 10x minus 21. That's the equation of the tangent. Okay?
Yo, this one is less complicated.
I'm listening.
I'm saying Sir's equation is less complicated than the one I was doing.
Okay, this, which one? You guys, when you calculate, you use this one, y minus y1, it's equal to m into x
Yes.
minus x1.
Yes.
I think even this one, man, it's good. It's just that you have to make y subject of the formula, multiply out the bracket by the gradient, which is where you can just make a lot of mistakes. Ne?
Yes, I like this one. It's more straightforward.
Okay, I understand you. Ne?
Okay, so
7.4. Look at 7.4. They say that they want you to find the graph G prime has a minimum turning point, okay, at
mm-hmm.
1 and minus 4. Oh, determine the values of x. Okay, so this 7.4 is no longer part of, 7.4 is on its own. Ne? This is a new question. Again,
Okay, so
okay, do you want me to give you a chance to try how to answer this 7.4?
no,
Okay,
no.
look at this. Now, they say that the graph y is equal to g prime at x. And then when you see the weight minimum, just know that we're talking about the first derivative. Né?
Okay,
Okay, we are referring at the first derivative. But now, it has the minimum. So they are talking about the turning point at that point. So it has the minimum turning point. So I'm not sure how can I show you this? If I have a graph like this and they say it has a minimum, so this is my minimum turning point. This is my minimum and this is my max. You understand?
okay,
And
okay.
then they say determine the values of for which G is concave up. Ne? Concave up. So
Yes.
if we determine the concave up, we're going to find the second derivative, and then it must be greater than 0. You understand?
Yes.
Okay.
Because
So
it's
now,
concave up.
yeah. So now, when this graph has the minimum turning point, it tells me that I'm just gonna quickly give you an example. Né? So you see this point, this x value. Okay,
Yes.
so this x value, it becomes what we call, since is the second derivative is it becomes what we call the point of inflection. You understand?
Okay.
The point of inflection is where the graph changes the concavity.
Okay.
So when they say it has the minimum turning point at that point, and they say for which values of x is the graph concave up, you need to take the x value, which is 1. So x must be greater than that 1. That's the answer. And when they say the graph is concave down, it will be x must be less than that 1. So this one is for concave down, and this one is for concave up. So you just have to understand that the second derivative, it should be greater than 0. And then for down, the second derivative, it should be less than 0.
Okay, sir.
Are you happy with that?
Yes, sir.
I'm moving. I'm moving to the next question. Question 8. What's wrong?
Let's move.
Yeah. So when I look at this question 8, they say you are given f at x is x to the power 3 minus 8x squared plus 5x plus 14. And the question says they want you to show that, write down the y-intercept of f. So you don't have to make any calculations. Just give us the answer, and you will give you that 1 mark. So can you please tell me what will be the y-intercept here? What do you think will be the y-intercept?
You're 14, negative 14.
Let me remind you something. Let me just put something down here. The y-intercept, we find it if x is 0. And you don't have to do any calculation. Tell me the y-intercept. Already we know that the x coordinates is 0. What is the y?
3. Okay.
Come on, Emerson. If x is 0, look at the equation.
Yeah, man, give me 2 minutes.
No, you don't need 2 minutes. You need 10 seconds.
Yeah. Hi. It's 14.
It's 14. You don't have to do calculation. You
Yeah.
go to your graph, you look at the one that doesn't have x, which is 14, then you write it down here. Okay?
Okay, then.
Don't waste time on that. And then the next one, they say that show that x minus 7 is a factor of f. So if x minus 7 is a factor of x, this tells you that if okay, so let me explain this like this. So if they want you to show that x minus 7 is a factor of x, remember that if something is a factor, when I say x minus 7, I equate that to 0. What do I get? I get x is equal to 7, right?
7. Yes.
So this tells me that when I find f at 7, the answer should be 0. So on the original equation, when I substitute 7 on that original equation, I should get an answer of 0. So from f at x, so I'm going to say this is 7 to the power 3, then minus 8 into 7 squared, then plus 5x. If you get 0 here, then x minus 7 is a factor.
Okay.
Okay, this is plus 14. Therefore, f at 7, this should give you 0. So since it's 0, then we can say it's a factor. You understand?
Okay, Mania.
Did you verify that using your calculator?
Yes, it is zero, so it is a factor.
Okay, no problem. All protocols are reserved. Let's go to the next question. Hence factorize. So hence means that use what you already have. Look at this. When you factorize, already we have x minus 7 as a factor. So I'm doing 8.3 now. So when I have that as a factor, I'm going to open two brackets. Look at what I'm doing. We take the x, you divide that x to the power 3. So it will be like x to the power 3 divided by x, which gives us x squared. The answer that you get, you write it down here, x squared. And then you take the minus 7. Don't say 7, but minus 7. You're going to take the positive 14. You see, I take this with the signs. Then you divide that by minus 7, which gives us minus 2. So this part here will be minus 2. You're still with me?
Yes.
The middle part, I'm going to say this is kx. Now, the aim is to find the value of k. And we're going to do this by inspection. So when I say we're going to do this by inspection, you're going to create maybe the coefficient of x. Let's create the coefficient of x. To create the coefficient of x, I can say this x times that minus 2 will give me the coefficient of x. And then another one that can give me the coefficient of x is this one and that one. Look at this. If I say minus 7 times x squared, that doesn't give me the coefficient of x. So you can choose if you want to create x or if you want to create x squared. So when I multiply the two, I'm going to say this is it's x times minus 2, which is minus 2x. Then minus 7 times kx, which is minus 7 kx. Then you're going to equate this to the term that has the coefficient of x in the equation, which is 5x.
Okay.
Then this side we have a common factor. Okay, this is minus 2x. We have a common factor of x. I'm going to take that out. Then I'm left with minus 2. Then this will be minus 2 minus 7k. And then this is 5x. Divide both sides by that x. Divide both sides by that x so that we get rid of that x. The aim is to calculate x, k, remember? So this will be minus 2
Yes.
minus 7k is just 5. Therefore, let's move the 2 to the other side. This will give us minus 7k to be 7. You understand? Because the 2
Yes.
comes this side to be plus 2. Then if you divide both sides by that minus 7, this gives us
Negative
k to
one.
be negative 1. Let me see. Look at this. What I'm saying
Yes,
is
sir.
that we can. It's up to you which coefficient you want to use. Look at this. I can create. Remember, I have x minus 7. Then I open the brackets, and then now I know that x to the power 3 divided by x, this gives me x squared. Then f plus 14 divided by minus 7, this gives me minus 2. The middle term is plus
Yes.
kx. So I can also, on this one, I can also create the x squared. Look at this. I can say this times this will give me x squared. This times this will give me x squared. So this will be uh, kx squared minus 7x squared. Then equated this to the term that has x squared, which is minus 8x
Oh,
squared,
okay.
right? So I can take
Mm,
x squared out as a common factor. I'm
out.
left with k minus 7. And then this is minus 8x
Okay,
minus
but the
8
rule is to
percent.
cancel out x all the time.
Yes. So this is
Okay.
x squared. This is x squared. Therefore, I'm left with k minus 7 is equal to minus 8. Therefore, k will be minus 8 plus 7, which is minus 1. So it's
Negative
up to you
one.
what you need to work on.
Okay, sir. I
Okay,
get it.
so now to factorize this completely, we need to put that equation back there. So to put the equation back,
Yes.
this is what I'm
Yes.
going to have. I'll have x minus 7 into, this will be x squared minus k, which is minus 1. Then I have
One.
x minus 2. So can you see that it will be easy for us to factorize that other
Mm.
part?
Yes, sir. I do.
Okay, so
Makes
when
sense.
I
Yes.
factorize the
Yes.
other part, this will be x minus 7. This will be x. The factors of 2 is just 2 and 1. Then since
Nice one.
it's negative, one should be negative, one should be positive. We'll give the bigger number negative sign, the sign of the middle one. Then this is fully factorized. Then you are done.
Mm.
This is factorized. Okay, so let's look at what they want us to do at the next point. Oh, determine the coordinates of the turning point A and B for 6 marks. You see, this is just easy marks. Now, how do we find the turning point? I'm just going to write f at x in the meantime this side. Do you know how we find the turning point?
No.
Eh?
No.
The turning point of a cubic function.
No, I don't know.
Ah, come on, Emily. Please don't do this to me. Hmm? Are you sure you want to do this
No.
to me? Amy,
Sir?
you sure you want to do this to me? When you are writing this grading, are you sure?
Oh, sir, that's how many
Ah, come on. Remember, when we find the turning point, we find the first derivative, we equate it to 0. Then solve
50.
for x. So
Yeah.
the first derivative of that equation, it will be 3x squared minus 14x plus 5. Then equate that to 0 and solve for x. You understand? So, no, this
Yeah.
is not 14. This is 18. I 16. It's 2 times 8.
8, which is 16. Yes.
16x. Then we add 5. This is equal to 0. Then now you factorize. This will be 3x. This will be x. Then we need to have uh, the factors of 5 so that when we add or subtract them, they give us the, what is this? They give us the middle term of that 16. So this is 5 and 1. Look at this. If I put the 1 this side, 3 times 1, it's 3x. Is 3x close to 16?
Is 3x close to 16?
Yes, I'm asking. It's very
No.
far. It's far. But look at this. Then I changed, I put 5. What is 3 times 5? That's 15x. Is 15 close to 16?
15. Yes.
Then the 5 should be on that side. 1 should be this side. Then now we need this 15 to be negative and also that one to be negative because of this is plus 5. Né? Therefore, this is
So
0. I'm
can I
listening.
just use that negative b plus minus square root b minus
Yes.
4ac for this, right?
Please listen. There's a mark for factors. When you use it, don't write it on the question paper. What you can do, you can, when you use it, this is how you should use it. Né? You can use the quadratic formula, and then the answer that you get, you're going to get that your x is equal to 5, or the value of x is equals to 1 over 3, right? So we need to see
Yes.
the factors. You take the 5, you bring it this side. You write this as x
Okay.
minus 5 is 0. Then you write the x minus 5 as your factor.
Okay,
Then
so
this side, this is over 1. You cross
28.
multiply x times 3. That's 3x, which is equal to 1. The 1 comes to the other side. 3x minus 1 is equal to 0. Then you write the 3x minus 1 on the bracket. So please, when you use the
Okay.
quadratic formula, don't write the quadratic formula because there's a mark for those factors. They need to see the factors.
Okay, sir.
Oh, okay. Uh, Now, what I'm going to do, I'm going to solve this equation by saying that x is 5 or x is just 1 over 3.
Over 3.
Right. So these are the x coordinate. We need to find the corresponding y value, which is f at 5. We also need to find x
Mm.
at 1 over 3 on
Yes.
the equation. So x at 5, that will be 5 to the power 3
3.
minus 8 into 5 squared plus 5 into 3, not 5 into 5,
Into 5.
and then plus 14.
That's going to give you negative 36.
It gives you negative,
36.
okay, negative 36. So this tells you that the first point is 5 and negative 36. Then what is the next one? Uh, this is 1 over 3 plus 40. Therefore, what do you get?
So should I give it to you in fraction form or decimal form?
I think in fraction is fine.
Okay, so I get 400 over 27.
400 over 27. Then in decimal form, what do you get?
I get, okay, so I'm going to round it off, so it's 14.81.
Okay, thank you very much. Okay, so now that's how you find the turning point. Now, please don't disappoint me. Nah?
Yes,
Don't disappoint me. You know what? So now when I look at this question, uh, I'm gonna say that uh, okay, the answer this side will be 1 over 3 and that 400 over 27. That's the answer. So these are your turning points. Né? So which one is A, which one is B? They say the coordinates of A and B. Look at where's A. So A, x value of A. If you look at this, the
and a
x value
positive
of A,
y
or
value.
we can even look at the y values. This one
Yes.
has a positive y value, or this one has a negative y value, then A has a positive y value. So A, this one will
Is
be
there,
point A, and this one will
and
be
B will
point
be
B.
that one.
Okay, let me look at the next one, number 8.5. So find the coordinates of the point where the concavity of the, you see, remember we just talked about this on the previous question. I said the concavity changes on the second derivative. So to
Second
find that
derivative.
point, you need to find the second derivative of x and equate that to 0. So if this is my f at x, so what will be the second derivative? So we need to derive that first derivative. So if you still remember, the first derivative was 3x squared. Then we said this is minus 16. This is where
Minus
we made a
16
mistake and said that was 14x. Then plus 5.
plus 5.
So if I
Yes.
find the second derivative, what is the second derivative equals to? So this will be 6x minus 16 is 0. Then you solve for x. So this will be 6x, it's equal to 16. Divide both sides by 6. Therefore, what is x equals to?
That is equal to 8 over 3.
Okay, so x is 8 over 3. The question
Yes.
said, find the point. We have the x, we need to find the corresponding y. We have to use the original equation to find the corresponding y value. So this will be x, which is 8 over 3 to the power 3. Then we're going to minus 8 x squared. Then we add 5 into 8 over 3. Then we add 40.
That's going to give us Negative 286 over 27.
You see, when I'm in an exam and I find this type of answers, I feel like whatever that I'm doing is wrong.
Yes, sir.
Then
Negative 286, sir. 286.
286, ne?
Yes.
Right, and that's it for this one. Then the point will be, your point will just be those two. So your point will be, therefore, your point will be 8 over 3, and that negative 286 over 27. That's the point of, that's the concavity point. Are you happy with how we did question 8?
Yes, sir.
Right. You mind if we just skip this question 9, and then let's do the last question. I want us to do, let me check how much. Okay, we only have 8 minutes left. So this one, I'll teach you how to draw a graph if you are given the what is this? This information. I'll do a recording and I'll send you the video for you to watch. So now I want us to
Okay,
use
sir.
the remaining, uh, the last minutes. Let me check how long we have. Uh, Okay, so now let's look at this question 10, and this will be the last question of this paper. And then I'll send the
Okay,
video on
sir.
question 9, and I'll also send the video on, I think last time we were, okay, I think we did explain everything here, né? I think we did explain everything on this question paper. So I'm happy that we did everything on this paper. So let me just quickly explain question 10. So on question 10, it has to do with optimization. Né? So this one is
Okay.
one of the easiest question, and you don't have to lose marks here. A stone is thrown upward and its height after 2 seconds is given by the equation. Determine the height of the stone after 2 seconds. Look at the mark allocation, 2 marks. So this tells you that where there's t, you just substitute 2.
Yes,
So this will
two.
be h at 2, which is equals to 18 into 2 minus 4 into 2 squared. You punch that on the calculator, find the height of the stone after 2 seconds.
It's
Okay?
20.
You get
Yeah, 20, sir.
20 meter, right? Because they said
Yes.
meters. Then the next question, determine when you see the weight velocity, né? When you see the weight velocity,
Mm-hmm.
you find the first derivative. So I'm just going to put that here as an exam tip. When you see the weight velocity, it means find ah prime at x. Then substitute that where to get the velocity. So we need to derive this guy. So we need, if h at x is equals to 18 at t minus 4 t squared, what is my f prime at x? So the x prime at x is just, this will be
20.
18 minus 8t. And then we need to find h prime at half second. So it's like saying 1.5 seconds is 1.5. So we need to find 1.5. So this will be 18 minus 8 into 1.5. Easy. The most important thing, when you see the weight velocity, find the first derivative. Né?
Okay, sir.
And
And
then
that
what?
is 6.
I'm listening.
That is equal to 6.
Okay, 6. And this is velocity. It should be in meters per second. Since you're doing physics, you understand that part. Né?
Yeah.
Okay, the last question. What is the, you see the weight maximum? When you see the weight maximum, what do we do? Remember, the weight maximum means that find the derivative, equate that to 0. So when you see the velocity, you find the derivative. Where there's t, you put the time. So now they want the maximum height that the stone will reach. You first find the first derivative, and then you solve for t. We're going to use that time to find the height. So this is going to be, we know that the derivative is 18 minus
Minus 18.
8t, equate that to 0 and solve
Solve
for
it
t.
to
So
0.
this is 18 is equal to 8t, divide both sides by 8. Therefore, what is t equals to?
T is equal to 9 over 4.
9 over 4 in decimal form,
Yes. Yeah. In decimal form, it's 2.25.
2.25 seconds. Then you take this
Yes.
time, né? You're going to substitute on the original equation to find the height. So we have to find h at 2.25. 0.25. These are one of the most important, oh, not important, but easy question. I'll explain the when they are easy and when are they hard. You know?
Okay, so we're gonna substitute this 9 over 4.
And what is the height?
Minus 1, 9 over 4 squared. The height is 81/4.
You got
In decimal form, it's 20.25.
20.25
Yes.
meter. That's the height. So, you know, when these questions are hard, they are hard when they give you something like uh, a certain shape, maybe a cylinder, maybe
Yes.
something. You see, when they give you a shape, you just have to remember the formulas on measurement. So, to master this topic, you also need to
You
revise
must know
measurement.
those
Né?
formulas.
So, now
Yeah.
I'll explain this question 9. I'll definitely send this to you. But look at this hour. We covered 3 questions: question 7, question 8, and question 10. I think we did a very good revision, right?
Yes, sir. It was good.
Yes, and
Really good.
that's it
Thank you
from me.
enough.
Do you have any question based on what was covered today?
No, I just have questions on our lessons, obviously. Me and you, because we're gonna need a lot of lessons before Friday.
Okay. Uh, it's fine. I understand. Okay, great ones. As promised, guys, I said I'll put the question 9 at the end of the video. So I need to work out on this one, and I need you guys to comment on the comment section. Tell me what you think about my solution. So on this one, you know what I'm going to do. First thing first, I'll try to analyze what I'm given here. Let me check what I have here. Draw the graph of f if f at x is equal to. So we are given the standard form of the equation. I can see that. But you know, I'm going to try and draw this according to my understanding, and I need you guys to comment and tell me what you think, okay? Or if you have an alternative way to for us to work on this. So this is my uh, Cartesian plane. I'm going to draw my Cartesian plane like this. This will be my y, and this will be my x. Okay, so when I look at this Cartesian plane, I'm going to put my points. If I look at this, I'm just going to try and analyze each and every point. The first point says that f at 6 it's equals to 0. So remember, we find what we call the x-intercept if y is equal to 0. If f at 6 is 0, this tells me that this guy is going to be my x-intercept. So my x-intercept, the coordinates of the x-intercept, it will be 6, which is the x-coordinate, and 0. So I'm just going to put that point here. So this is my 6. Okay, the next point, right? Remember, the f prime is what we use to find the derivative. And when we say we use the f prime to find the derivative, so I'm going to have the derivative at x is equals to 0. Okay, so this is my TP. These are the TP as in like turning point, okay? So this will be my turning point. The x values of the turning points, already I know that the x values it's 0 and 4. Remember, when you find the turning point, f prime at x must be equal to 0. So they tell you that both f prime at 0 and f prime at 4, both of them are equal to 0. So we're going to have a turning point at 0, and we're going to have another turning point at 4. Right, I'm just gonna put that in that way. So now let's talk about the shape of the graph. Right? Let's talk about the shape of the graph. When I look at this, before I work on this part, I need to understand the shape of the graph. So I'm just gonna do this by inspection, because I know that to find the shape of the graph, I need to multiply out the brackets here. Look at this. If I have x plus p into x plus p, and this is x minus q. So x times x times x, this will give me x to the power 3. So this shows that the value of a, it will always be positive. Okay, so the value of a is positive. My graph should look like this. Okay, my graph will look like that. And so far, I know that I have the turning point somewhere at 0 and at 4. But I don't know if how this moves, if this moves like this, or if, but let's work on this. Let's use the remaining points to find the solution of this graph. So now they say that, look at this, the next point on this point here, they say f prime is less than 0. Guys, when we talk about f prime being less than 0, this, it's like, where is the graph decreasing? Okay, so f prime less than 0, it tells us about if the graph is increasing or decreasing. So f prime is less than 0. Let me write this down. F prime is less than 0. It tells us where the graph is decreasing. So this is decreasing. This is decreasing. So decreasing, it means that the graph is decreasing between 0 and 4. Okay, okay, it is, oh, okay, let's put it like this. And I think it's best if we say is decreasing between 4, it must be less than 4. So if this is 4, this is my 4. Okay, so this is my 4. And then let's first talk about the local and the minimum. So I need to understand what is my minimum, and I need to understand what is my max. So it's either your minimum, if you look at this, we have 0, and 4. So if they say that this one here, this one is what I'm going to say. I'm going to call this, what is this? We're going to say is decreasing in this interval, okay? So in this, the interval is decreasing, and the graph f prime is greater than 0. In this interval, it's increasing. So if that's the case, look at this, is decreasing, it's increasing if x is less than 0 and if x is greater than 0. So the minimum will be at 0 and the max will be at 4. So at 0, we're going to have the, what am I saying? This is not right. The max is the one that will be at 0. Let's fix that one. The max is the one that will be at 0 and the minimum at 4. The max at 0 and the minimum at 4. So now, when I have this, I'm going to say at 0, since this part should be my 0 because it's my max. So this should be 0 and this one should be 4. So this tells you that this part will go like this, and then somewhere down there, this part will go like that. I hope you guys understand. Then you just have to connect the dots like this. I don't know, guys, if you really understand my solution. That's why I'm saying that if you don't understand this one, it's okay. That's why I need you to leave a comment on that section. So let me explain what's going on here. So they say that f at x, it's decreasing x less than 4. So you can see that from 4, this point here, the graph is decreasing. Look at this. The graph is decreasing. X less than 4, the graph is decreasing. So this point here, let me indicate that with a different marker. This part here, your graph is decreasing, which is that part. Less than 4 and greater than 4. This is the mark. Okay, which is that blue part. And then this part less than 0, it's increasing. If this is you and you are moving from left to right, you see that the moment you go through this part, you are up the slope, so you are increasing. Okay, and then x greater than 0 is also increasing, or x greater than 4. From 4 going up, you are increasing. I hope you guys get this one, but if you don't get it, it's okay there. So let's plot this graph. Let's put that point on the graph. We know that if this is my 2, minus 16 is somewhere somewhere then. So minus 16 is somewhere here. And then you can just plot that graph and say this is 2n minus 16. Okay. Okay, I think that's it, because f at 2 is equal to minus 16. I think this might be the point of inflection, but we're not sure. I don't know. If you have another method, I would really appreciate if you can just comment on the section and tell me what you think and which method do you prefer us to use. Then yeah, we'll take it from there. Thank you very much, guys, for watching, and I'm looking forward to see you guys on the next lesson.